What's up guys, welcome back to another tutorial. Today we'll be making a very simple play controller for 2D games in Unity. Before we get started, my name is John Stayskull. I've been making games for over 10 years now. I'm currently working on a Viking adventure platformer called Blood and Mead. So hit the subscribe button down below and make sure you hit the bell notification too to get a heads up for any new content. Okay, let's get going. So let's get started by opening Unity, making sure our Unity version is up to date. And here we'll create a new project. Let's call this Simple Player Controller. Simple 2D Play Controller. And from the template dropdown, make sure we've got 2D selected. That'll give us all the presets and orthographic camera and out-of-the-box tooling that complements our 2D workflow. Alright, now that Unity is open, we can see over here we've got a main camera and that's it. So first thing we're going to want to do is click over here in our project tab and we see we've got an assets folder. So what we'll want to do for step one is to create a couple more folders that we can use. So right click in the assets folder and create a new folder, and we'll call the first one graphics. And here in there we'll put all our sprite sheets and backgrounds and all that stuff. Create another one and call this one animations. So I've got a few pre-made sprites here that I'll be using. We've got like a Mega Man sprite sheet, a platform and a background. So what I'll do, I'll grab all these three and drag them into the graphics folder we created. So let's close that off and we'll find now that in our graphics folder we've got background, platform and player. So for step two we'll be creating our first animation. Click on the player object over here and here we get all the information on the on this graphic. And we can see that the sprite mode is set to single. In this case we want it to be multiple as we'll be using different frames. And click on Sprite Editor. Let's apply that. So in the Sprite Editor here we get to slice up our animation in a way that we can use. So over here, leave that as automatic. We change the pivot to bottom, which will kind of put it in the middle, bottom. And let's hit slice and see what happens. Alright, so we can see now that Unity has sliced up around the bounds of the graphics, so that's kind of cool. So what we'll want to do here, you can also see that Unity has named it in a bit of a funny way, just a 1, 2, 3, 4, 5, 6 kind of situation. So let's call the sprites by their correct name. So we'll call this one idle 1, player idle 2, this one is jump, which is a single frame. And then we've got 3 run animations here. So player, player run 1. And run 3. So we've got a bunch of other animations that we're not going to be using in this tutorial. So let's just select some of these extra ones and delete them just to make the project a bit simpler. I'll probably make another tutorial later on dealing with shooting and stuff like that. And let's hit the apply button in the top right over here. And close it off. If we hit this drop down on our player object, we can see the different animation frames that we created. So now we'll start by creating our first animation. And in this case, we're going to be making the idle animation. There's a few different ways to create animations in Unity. My personal favorite is to select the different frames holding shift that we want to use and drag them straight into the scene view. And this will prompt us to create a new animation. So we'll navigate up to the animations folder we created and call this one player idle. Save that. Okay, so now we've got a player in our scene. And we'll notice down here in the preview that the sprite is very small. Click the main camera, and we'll just want to go over here and change the size a bit so we're better in frame. And you can also drag the bounds of the camera here. So we'll try to get that about like that. So we'll just click play on this and see what happens. Okay, so we see down here Mega Man's going into an epileptic blinking frenzy. So we'll close that off. So what we need to do here is actually address the frame rate of the animation, because by default Unity sets it to 12 frames a second. With our player selected, let's click the animation tab down here, and you can see here the player idle animation has 12 frames a second frame rate, and here are the two different frames. So that's frame 1 and frame 2. So we can actually preview animations here, so we can see what's going on here. It's just looping very, very quickly through that animation. So if we change that to say 4, we can see it's got a much slower cycle. So what we might want to do, let's drag this across there. So we'll select this first frame, Control C for copy, and bring it over here, and Control V paste. So now we've got him opening and closing his eyes. And what we'll do, we'll just bump this over, and we'll paste another copy of that frame over there. So now if we expand this out, we can see the whole playhead. We'll click play, and you can see what's going on now in the preview. He's opening and closing his eyes, and it's like a delay. So we can extend that delay out even further by dragging it on there. That looks pretty good. That's not too far off what the original Mega Man behaved like. We've now actually created the player object already by making this animation. So we can see here, it's by default called it player idle, which was the name of the first frame of the animation. So let's click that and rename it to player. And you can see a few different things attached to it. The sprite renderer, an animator. So you may notice that Mega Man is looking a little bit artifacted in terms of the graphic fidelity. Being pixel art, we want this to be really sharp. What we'll want to do is go back to our animation component over here. From the filter mode down here, which is currently set to bilinear, we want to change that to point. So point is what we'll use for pixel art, and bilinear and trilinear are useful for like vector art or any other non-pixel art formats. Click that, and wow, look at that. Automatically, that just went super crisp. Magic. So that's perfect. So let's now create our run animation, which will follow the same process. Shift select frames 1, 2, and 3, drag them into the view, navigate up to our animations folder, and this time we'll call it player run. Save that. And if we just preview our scene now, we should get both animations playing here at the same time. Oh, Mega Man clone! Okay, so what that's actually done behind the scenes is created the animation, so we don't actually need this game object in the scene view anymore. We can delete that one, because we'll be actually using this one here, and then attaching that animation to this one. So we can do that quite simply by selecting our player, going up to the animator tab over here, and we can see here we've got the player idle. So this is Unity's mechanism feature, which is used for creating and managing transitions between animations and things like that. It can get pretty complicated, and it's kind of beyond the scope of this tutorial, so we'll just use it in the bare minimum way. So we'll go to our animations folder over here and grab the run animation, which is identified by this little box with an arrow, not to be mistaken with the one underneath it, which is the animation controller, which gets automatically generated when we create an animation. So grab the player run and drag that into here. So we've got the idle and the run. And here you can actually set the default player animation by right-clicking and set as default. So when you do that, it basically says make the player run straight away, or make the player idle straight away, which is what we want in this case. So going back to our scene view, we'll want to click our player, go to the animation tab, and what we'll notice here is now that here we have the run animation. So if we select that, we can preview the run animation, and that looks actually pretty good. I don't mind that. I might just try lowering the frame rate to 10 in this case and see how that looks. Let's try 8. What do you guys think? Kind of 8, 9, 10, I think anywhere. But let's stick with this kind of sweet spot of 9. Kind of looks all right. So the final animation we're going to be making is the jump, which is a unique case because it's a single frame. So what we'll want to do is navigate to our graphics folder, select the jump, and see what happens when we drag that in. And you'll notice that we don't get the same automatic prompt to create an animation because it's only one frame. And it's like, well, it's not an animation. What are you trying to do? But here we do get this option here to create it. So let's click that and we end up with the same option. So navigate up, and this one will be called player jump. Start. Save that. Okay, so, and once again, we'll delete this one. Click back to our player. We need to add the jump to the animator. So let's go over to the animator here, click on our animations folder, find the jump animation and bring that in here. And you can kind of organize this however you want. These windows can get pretty complex. If you can imagine, some games have, you know, over 30 animation states depending on what kind of game it is. Go back to the scene view. With the player selected, we'll notice now we have a jump. It's created an empty animation, which is kind of what happens when you try to create a single frame animation. But it's an easy way to fix this. With this window open, click on our graphics folder, find the jump frame, and drag that in here. And look at that. We have a one frame animation. And it's just going to be looping over itself, which is fine, which is exactly what we want here. And in this case, the frame rate, it doesn't matter. So Unity is giving it a 60 FPS as default. Cool. So at this point, we'll add the background components to kind of jazz up the scene a bit and get us on the path to floor collision and movement. So go back to your graphics folder. You've got your background here. Just make sure that's set to point. Floor is set to point. And we'll drag the background into the scene. Drag the floor into the scene. And we'll notice that the kind of proportions are a bit off at the moment in terms of the background scale with Mega Man. I mean, ideally you want things to be scaled correctly before they come into Unity, if you can. You can play with it in Photoshop or whatever. But here I might just kind of tweak these things. Mega Man's looking a bit big at the moment. So rather than scaling him down, I might scale the background up. So grabbing the background and floor, holding shift, I might just bump up the scale in the properties inspector over here to 1.5. So that looks a bit better. But what I'll want to do is maybe rescale the camera a bit too. So clicking main camera, you can grab the scale tool or one of these ones and grab the handles here. So we might see what happens when we do like that. All right, we'll go with that. I mean, depending on the assets you're using, you're going to want to kind of tweak the camera position and the camera size so that your graphics fill the screen properly. But I think that's looking pretty okay. So at this point, we'll add a box collider. So select the player, and down here we'll click Add Component. Type in box. You should automatically get some auto-completed results. And what we'll want to add is a box collider 2D. And this is the box that will be used for collisions with the rest of the world. And you can see Unity has automatically used the Sprite's boundaries to set the size of the box collider. But you can see here that the box collider is a bit lower than the feet, so I might want to move that up a bit. So over here on the box collider settings, you can actually edit the collider. So if you press that, that'll toggle and the collider is now in edit mode. So what you can do here is you can grab the handles here and you can kind of change the collider manually. So that's really cool. So once we're done with that, we just kind of untoggle. Now we're going to want to add a rigid body. And the rigid body is a physical component that we're adding to the player to say, now I want you to obey the physical laws of the Unity world. So over here we'll type rigid body, and we'll want rigid body 2D. So that adds now all these physical settings to the player. Gravity scale, mass, weight, how heavy the player should feel in the world, and stuff like that. So we'll kind of leave that as is and see what happens. Wow! Okay, so Mega Man just took a dive. So now we need to add a floor to give him something to stand on. So let's select our floor game object and add a box collider component. Enter. So now you can see that the floor itself has a box collider. Cool. So if we kind of put this guy in the air, run that again, boom. Okay. And you might notice there was a little bit of kind of overlap with the floor when we dropped it. If you just kind of watch this again. Yeah, he kind of goes through the box collider and comes back. You need to kind of adjust the physics settings a little bit. So what we might do, click on the player, and here we'll change the collision mode to continuous. So that takes a little bit more resources, but it just gives it more accurate collisions. So let's have a look what happens now. Okay, so that's perfect. So that lands right flush on. We'll just position Mega Man down here. So what we'll need at this point is create a C# script. So clicking on the player, we'll go down here, add component, and this time we'll select new script. And we'll call the script player controller 2D. Create and add, and that should add it directly to the player. Time to code, my friends, time to code. So now if you double click down here, it should open Visual Studio. And we want to start by feedback. Yeah. So we want to start by creating 3 different properties that we're going to be referencing. The first one is the animator, which will be used to switch between animations. Then we'll need the to reference the rigid body. So rigid body 2D. We'll call that RB2D. And finally the sprite renderer, which we'll use to kind of maybe flip the player as we turn left and right. Call that sprite renderer. So down here we want to kind of map those properties to the components. So animator equals get component animator. Whoa. Okay. Jesus. Rigid body 2D equals get component rigid body 2D using Visual Studio's very awesome autocomplete system. Sorry guys, I can't type today. Sprite renderer equals get component Sprite renderer. All right, so now what we'll want to do is map the keyboard buttons to move the player. So what we might do, we might map the A and D keys for moving left and right, but also maybe the left and right arrows. In another tutorial, I might talk about like Xbox controllers and stuff, but for now we'll just use the keyboard. So this can be done in the update loop, which is the Unity's game loop, but because we're using physics, what we'll do is create a fixed update. And this is similar to the update function above, but it's got a fixed time step and a bit more accurate for games that are based in the physics world, which this one is. So I might actually just delete the update function. And in here we'll say if input dot get key, and in here we'll say D, oops, or input dot get key right. My auto completion skills are not working today. Then rigid body 2D dot velocity equals new vector 2, and here we'll give it a velocity. So let's try 2 for the X and maybe 0 for the Y. Else if input dot get key, this time we'll say A, or input dot get key left parentheses. So now we'll say rigid body 2D dot velocity equals new vector 2, and this time we'll say -2 and 0. Okay, so let's see what happens now when we run the scene. See if I press, whoa, cool, it's like ice skating, yeehaw! Very nice. It's like it's gonna teleport out. So that's cool. We've got movement. Yay. It's not quite a game, but it's always nice to see some movement on screen. Now we'll map the spacebar for the jump. So we'll say if input dot get key space, and now we'll say rigid body 2D dot velocity equals new vector 2. So we don't want to interfere with the horizontal movement of the player, so we'll keep it mapped to whatever it already is. So we'll say rigid body 2D dot velocity dot x, so we're not changing that. Instead we want to change the y. So for the jump we'll say, I don't know, let's just say, let's say 3. So now let's press the space bar. Wow, okay, we have a jump. So now we can, oh, whoa, what's going on? This is the cool part of starting a new project where you can kind of tweak things around and quite often come up with a whole new game idea, some emergent games. Like this could be some kind of a, I don't know, floaty game. Some kind of bird or dragon floating down and collecting stuff. And yeah, so we got a few issues here. We'll want to make sure that our horizontal movement is not interfering with our vertical velocity. So we'll say rigid body 2D dot velocity dot y. So we're not overriding what's already happening vertically, if that makes sense, for the left and right movements specifically. Okay, so we're not getting that kind of floaty movement we were getting before. So we're getting a little bit closer to a kind of reasonable result. What we might do now is change the animation so it looks kind of cool as we're demoing it. So what we'll do, we'll reference the animator we created, animator, and we'll say dot play, and here we'll put the name of the animations we created earlier. So we had like player underscore idle, player jump, player run. So here we'll say if the player is pressing right or the D key, then player run. So we'll just copy and paste that down here, and we'll do the same for the left. And for the jump, we'll say jump. Oh, and also here, we'll put another else condition. So if the player is pressing left or right, then play run, else revert back to the idle state. So player idle. Wow. Yeah. Yeah, some few crazy things happening. It's moonwalking though, that's kind of cool. Okay, so let's fix up all that stuff. So the first thing we'll want to do is flip the player when he's going left. So say sprite renderer dot flip x equals true. If pressing the left, flip it, and if it's pressing right, then don't. So let's preview that. Okay, so that's working, but the player's got a lot of kind of slide momentum, and there's no real resistance on the floor, which is likely to do with the player's weight. So oh, actually, I know what it is. I know. Okay, so if the player is moving left or right, we're bumping the velocity. So let's say if he's not moving left or right, then let's change the velocity to 0. How's that sound? Okay, cool. So look at that. Now we can run and stop on the dime. Perfect. So that jump has still got issues, which we're going to look at now. That one's a bit more complicated to solve, so I thought it'd be nice to kind of get this running action happening. Yeah! And Mega Man is the best, I've got to say. Mega Man 3 was easily my favorite one. So if we click on floor and we go to the property inspector over here, we'll see that the layer is by default set to well, to default. So what we want to do is add a layer, and here we'll call the layer ground, and select our floor again, and from here choose the ground layer we just created. We'll have to now shoot like what we call a line cast from the player down towards the floor. This is a very typical technique used in Unity in games, and you'll see it quite often, regardless of it being physics or not. It's just a very efficient way to determine if the player is on the floor. So click on our player again, and what we're going to do is this time we're going to right click and create empty. And what that'll do is create a game object within our player. So what here, we'll name this ground check. And if you click over here in the inspector, you can give it a graphical icon, which you can change the size of it with the gizmo drop down over here. So we'll make it about that big. So what this will be used to do, we're going to shoot a line cast, which is kind of a bit like a raycast, but a bit more of a simplified version, down from this point here, and we're going to shoot it down and look for the floor. And if it finds the floor, we're going to say that the player is grounded, and if it's not, then he must be jumping. So back in our script window, we'll want to do a few things. First, we'll create a boolean called isGrounded. Create a new transform, call it ground check. And what we'll do, we're going to serialize this field. And what all this means is that we're going to make it available in the Unity editor. So if we go back to Unity and we click on our player, go down to the player script, you can see now that ground check is exposed over here because we use that serialized field meta tag. So what we're going to do here is, well, we can do two things here. We want to map this ground check object we created on the player and bring it down here. So you can do this one or two ways. You can click this little knob here and find the ground check here and select it there. Alternatively, you can grab it from the scene hierarchy here and drag it all the way across and straight into there. So that's up to you. Unity gives you a few different ways to do it, which is kind of cool. So take your pick. So in this next step, we're going to create the line cast. So what we'll do, we'll go to this fixed update method and type if physics 2D dot linecast, and we'll say transform dot position, which is the player's transform, and the second parameter we'll do the ground check object dot position, and here we are going to do like a mask layer thing. Name to layer. Don't have to get too caught up in how that works. It's basically saying if the line cast goes from the player to the ground object in that trajectory and it hits a layer called ground, then return true. So we'll say is grounded equals true, else is grounded equals false, which now allows us to manage the jump a bit differently. So in the jump, we only want it to be able to jump if the player is on the floor. So add another conditional in here and say if key is space and is grounded, is true, then jump. So let's go back to our game and see what happens. Cool. So now, as you can see, if you spam the keyboard spacebar, we can't fly off in the sky anymore. Oh, so that's playing a lot better. The jump animation is a bit funky at the moment still, but we can kind of sort that out now. So what we'll do here is, before the animations switch to run, we'll just make sure that the player is actually on the ground. If is grounded, then allow the player to run. Just copy and paste that over here. And same with the idle. We'll say if is grounded, then idle. So I'm hoping this will fix the jumping animation issue. So run the scene. Fingers crossed. Woo! Yeah. How awesome is that? Man, that, my friends, is a game. Well, not really. But it's a lot of fun. Yeehaw! Woo! 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 So we're going to change the physics properties a little bit. It's a bit out of control at the moment, just in terms of the speed. So we might close that off and change the velocity that we were using for the horizontal movement to about like 1. Right, what we'll do, we'll do a bit of best practices and actually make a property for this, and we'll call it run speed. If you highlight the property and tap, hold Control and tap the period or full stop, you can now generate properties from here, which is a really nice way to automate that process. So here we'll map that to 1. See how that goes. And we'll bring that over down to here too, but we'll call that, leave the minus there. Save that. It's probably about right, but so 2 things. I wouldn't mind if you jumped a bit higher and maybe you ran just a little bit faster. So let's jump back and change the run speed to, let's say 1.5. And we'll put an F next to it because it's a float. And maybe we'll do the same, make a property for the jump speed. So maybe we'll try about 5. And what you can do also, you can serialize these as well, which is kind of useful since you might want to tweak these a fair amount, and it just makes it a bit easier to have them available in the inspector. So if we scroll down here, you can see the run speed and jump speed is set here, and we can kind of do it through here manually. It's a bit easier. So we'll change that to 1.5, change that to 4, I think is a good number. Let's make the jump 5. Still not jumping as high as I want. Well, let's go a bit crazy here and say 10, just to see what happens. Aha! I didn't map. Of course, silly John. I need to go down to the jump and say jump speed. Okay, so let's try that again. This is currently mapped to, whoa, yeah, as expected. The dude just shot off to the moon. Which is kind of cool, which is almost that teleport effect that you find after the end of a level in the original Mega Mans. So let's go, actually, we'll do it in the property inspector. Let's go down here and change the jump to 5. Yeah, that's crazy. 4. Yeah, that's a lot more natural. I like that. That's really cool. That feels really responsive, and it, being a big fan of the original Mega Man, this kind of, it feels good. It feels great. It feels a lot like how I'd expect the original Mega Man to feel. I mean, I could be way off, but just in terms of what feels right and the weight and everything, this feels good. So what I might do now, just to make it a bit more interesting and more like a game, I'll bring a platform into it. So in the graphics folder, there should be a platform. Yep. So we'll bring that here, and much like with the floor, we'll add a box collider to it. And this automatically should allow us to jump and walk on it. Oh my goodness! What the devil? Oh no, help me! That's kind of cool. I kind of want to try that again just for fun. So what happened here? So I've got a feeling, yeah, just as I thought. Cool. So we need to lock the player's rotation. So click on the player and go under the constraints drop down and freeze rotation. So this will stop us from spinning around. Okay, it's got some... Right, so you guys want to guess what the problem is here? Why is that happening? Why is that not returning to the idle state? You may have guessed right. We need to make the platform part of the ground layer. So select the platform, and from down here, select ground. Okay, cool. See that? How cool is that? Wow, yeah! Woohoo! This is awesome. Oh, so we've got some issues getting stuck here, which is not, and obviously we can't go through the platform, but let's try to change that. So what we can do here is use a one-way platform. So let's see if I remember how to do this. So we need to make a platform effector, I think. Okay, that's it. Sorry, my brain was just ticking over there. It's a lot to remember often in these things. So in the box collider component, we want to toggle the used by effector just to let it know it's going to be using this component here. It's got to make sure I remember that. So one thing you'll notice here is now that we've added the effector, it's created this kind of arc, this half circle here. So this represents the range of the effector. So if we change this down here, you can see the arc is changing in shape. So we'll leave it as 180 and see what happens. Cool. So he's kind of coming through the floor and then kind of landing on it. And when we kind of come at it from the side, it's not as bad as before. Yeah, I mean, it's not perfect, and with any of these things, with games, you need to tweak them, you know what I mean? And going forward, if I was making a larger game from this, I would probably do a few things. I would create more ground checks. I would probably kind of duplicate that, put one here, call it ground check L. Oh, you know what? Let's just do it. Let's go for it. What do you reckon? Let's go for it. Let's stop mucking around. Call this one ground check R. Let's jump back to Visual Studio. So we'll want to expand this condition to check for a few more things. So we'll say or. Let's bring that over in line here, and we'll say ground check L. Ground check R. And we'll put this whole thing in one big condition. All right, so it's saying if there's a line cast between the player and the middle ground check, or any of those, then let the player be on the floor. Oh, we've got an error here. So we've got null. Ah, right. Okay, so we need to map those components to the player script. So here we can see the L and R are still null. So we'll drag the L over, drag the R over. It's kind of, yeah, so what's happening when the player comes off the end? Let me just pause that and have a look what's going on. So it's like it's not. Why are you not working? Oh, okay, I think I know what's going on here. Let's move these down a little bit. Oops. Yeah, there we go. That's better. So, yeah, again, you just need to tweak these things a little bit. And often with Unity, with making any game, you're always going to find little things that aren't working. So you just got to play with things. There's no hard rules. You're just going to kind of play with what works. He should probably be changing to a jump when he falls off. I'm noticing that he's breaking into a run. Let's see if we can fix that quickly. So is grounded. If it's not grounded, maybe when the player is not grounded here, I'm just going to give this a go. So basically you want to say whenever the player is not on the ground, you know, under any circumstances, then flip over to the jump frame. Cool. You see that? Oh, so now he runs off and he switches to the jump. Dun, 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 dun. Mega Man! Yeah, boy! Dun, 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 dun. I love this guy. So I'm pretty happy with that. That kind of sums it up, I think. Thanks for watching, guys. I hope you enjoyed that tutorial, and please do like and subscribe if you found it useful, and there'll be more content coming your way soon. Okay, see you guys.